Hello everyone, welcome to today's lecture. Today we are going to take a look at equivalent weights. Okay. Before this lecture we had already gone through the concept of oxidation state and oxidation numbers, how a redox reaction takes place, what is oxidation, what is reduction, what are oxidizing agents, what are reducing agents, and we also took a look at how to balance a redox reaction. Okay, we've taken a lot of examples of that, and there were two ways to do that. One was to first balance the half reactions and then add them up, and the other one was using the oxidation numbers and n factors balance the whole equation as a whole. I mean, just write the complete equation and then try to balance it without breaking it into half reactions. So we have already taken a look at that. Now the central concept of this chapter is equivalence or equivalence. Okay, now equivalence or equivalence. Okay, just imagine, like for example, if we have something called A plus 2B gives 3C plus D. Let's say we have this as a balanced chemical equation. Here you can see 1 mole of this will combine with 2 moles of this. So molar ratio is 1:2. But according to the law of equivalence, number of equivalents of A will always be equal to the number of equivalents of B. That will always be equal to the number of equivalents of C, and that will always be equal to the number of equivalents of D. That's how the law of equivalence works. Got it? So that is the law of equivalence. I'm not dictating it right now. I'm not going to describe it right now. Okay. The only thing is I'm giving you the context of our topic, which is equivalent weight. Equivalence, the law of equivalence, I've already given you some idea about it. But in that particular law of equivalence, we see something. What is that? Equivalent. Number of equivalents of A is equal to number of equivalents of B is equal to number of equivalents of C is equal to number of equivalents of D. Equivalents. What are equivalents? So to be able to define that, we first need to calculate something called equivalent weight. Okay, something called equivalent weight. Once we are able to do that, once we are able to calculate equivalent weight, we will be able to calculate equivalence. Mark these words. We are going to talk about this in the next lecture, but mark these words that if we are able to calculate something called equivalent weight, we will be able to calculate equivalence, and then we will be able to use the concept of equivalence or the law of equivalence. Got it? So law of equivalence is based on equivalence, and equivalence, like to be able to calculate the number of equivalents, we need something called equivalent weight. Got it? So first let's define what equivalent weight is. Another concept related to equivalence is n factor. We have already touched upon it. Today we are going to delve into it a little more. Got it? Let's first talk about this. Equivalent weight. What is equivalent weight? We have already heard of atomic weight, molecular weight, ionic weight, formula unit weight, or gram atomic weight, molecular weight, gram molecular weight, gram ionic weight, gram formula unit weight. We've already gone through these concepts. What is equivalent weight? We do not know. So to be able to do that, let's first define it. Equivalent weight is the amount of, or not amount, the mass of or weight of a substance that combines with or replaces 1 gram of 1 gram of hydrogen, or 8 grams of oxygen, or 35.5 grams of chlorine. If you remember this particular 35.5, 8 grams and 1 grams, this is somewhere you have already seen. You have seen it in valency. So there is some connection of valency over here. I'll tell you a little later. First, write the definition that equivalent weight of any species is mass of that species which combines or replaces 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine. Now let's take some examples. First example is Zn plus H2SO4 gives ZnSO4 plus H2. Here you can see that 1 mole of this reacts to give 1 mole of H2. Okay, in mass terms or weight terms, we can say that 65.4 grams of Zn reacted to give 2 grams of hydrogen, or not? Here you can see that it is replacing hydrogen. It is not directly reacting with hydrogen. It is replacing hydrogen. So we have already used that. Got it? Okay. So if we want to use equivalent weight, let's calculate equivalent weight by writing this. You can write it like this, or we can write it like this. This is equal to, so 65.4 grams are replacing or giving 2 grams. We want to know how many grams of Zn will give 1 gram. So if we divide it by 2 and divide it by 2, we will get it. But then again, I am giving you like a way. 65 divided by this, 65.4 grams divided by 2 grams into this 1 gram. This is a basic, this is a way of calculating this, and we will get it to be 65.4 by 2 grams, which is 32.7 grams. Got it? No. Second, just be with this. I'll explain everything and everything will be crystal clear to you. Just treat it like a movie, like a thriller. Okay. Second one is with oxygen. Let's take an example of Mg plus O2 gives MgO. Now here we already saw that, like, without even bothering, we can see that this was balanced, but this one is not. So to be able to prove this concept, we need to first balance this. If we balance it, we get this. Got it? Basic thing. Now here what it is saying, that 2 into 24 grams of Mg is combining with 32 grams of oxygen. Okay, if we are taking this to be 8 grams, how many grams of Mg will combine with this? So you can see we have divided this by 4. We will have to divide this by 4 as well. But then again, using this formula, E of Mg, this will be equal to, how to calculate that? This divided by the mass of oxygen, which is 2 into 24 upon 32 into 8. So if you can see, 4, 2, we get it 24 by 2 gram equals to 12 gram. Okay, this is the equivalent mass of, the equivalent weight of Mg in this particular reaction. Are we clear? By according to this definition, if we go, are we not calculating it correctly? Check it. 1 gram, for 1 gram of hydrogen, 32.7 gram of Zn are required. To combine with 8 grams of oxygen, we need 12 grams of Mg. Third one, let's take an example of 2Al. I am already writing it to be this. I have already balanced it for your convenience. We can see that 2 into 27 grams of aluminum are combining with 3 into 71 grams of chlorine. According to this definition, we want to know how many grams of aluminum are combining with 35.5 grams of chlorine. Okay, so equivalent weight of Al will be 2 into 27 upon 3 into 71 into this 35.5. If you divide it, we will get 27 by 3, which is 9 grams. So as per the definition, we have calculated molar equivalent weight of all these three species. I'll tell you how to use that as well, but then again, let's take baby steps. Let's first learn how to calculate equivalent weight. So we have learned how to calculate equivalent weight. We need to have a balanced chemical equation, and then by equivalence, equating these masses, we can calculate the equivalent weight. Okay, we need to remember 1 gram, 8 gram and 35.5 grams. We need to remember these figures. Got it? So by this definition, these are correct. But there is something which you might be wondering about. That is, why have I written these separately? I could have skipped this step. I could have also skipped this step as well, because I know if we divided 2 by 24 by 2, I would have gotten 12 grams already. Here as well, if I divided 27 by 3, I would have already gotten 9 grams, but I did not do that. I wrote it separately and then I wrote the final answer. Why did I do that? There is something curious happening over here. What is that? This is the gram atomic mass of Zn. This is gram atomic mass of Mg. Aha! Are you getting something? Gram atomic mass of Al. Getting it? So, if we look at it, can we say from these three examples that the equivalent weight of Zn in this particular case is its gram atomic mass divided by some number? For the time being, some number. Here, same. Gram atomic mass of Mg by some number. Gram atomic mass of Al by some number. Okay. Now this number is what is called N factor. This is what is called N factor, valence factor or X factor. Got it? This is something called N factor, valence factor or X factor. A valence factor is also given in some books. I prefer to go by N factor. So I am going to talk about N factor only. Got it? So as per this definition, if I want to write, so I have not dictated things to you. I'll dictate it to you, don't worry. Just let me write first the equivalent weight, the general definition of equivalent weight. Sorry, not the definition, but the formula. That is gram atomic mass or gram molecular mass or gram ionic mass or gram formula unit mass divided by N factor. Okay? Okay. So first write the definition of this. We have already gone through the definition. Write these examples and then we will move on to what I wanted to say. So from the above examples, write that. From the above examples we can see that equivalent weight of a particular species is equal to its gram atomic mass divided by some number, which is called N factor, comma valence factor or X factor, which is called N factor, comma valence factor or X factor. Okay? We will go with N factor. Now, there was something I mentioned in the beginning. The definition looks similar to that of valency. Don't you remember? Valency is what? The number of hydrogen atoms it combines with, or twice the number of oxygen atoms it combines with, or 1 times the number of Cl atoms it combines with. That is what valency is, how it is defined, how valency is defined. We will see that valency, this N factor is somewhat similar to valency, or you can say in general it is equal to valency. So write a note and write note करके लिखो, write N factor in general is the same as valency. N factor in general is the same as valency. That's first thing. Now, if you want to write an alternate definition of this, alternate definition of this, what will you write it as? You can write the alternate definition of this as equivalent weight is the ratio of gram atomic mass or gram molecular mass or gram ionic mass or gram formula unit mass to its n factor. That is the general definition of this. Okay. That's the whole definition thing here. Now, very, very important point over here that you need to notice that all these quantities or these numbers are calculated, weights are calculated for 1 mole of the compound. That means equivalent weight will always be calculated for 1 mole of the compound. Write that. Since GAM, GMM, GIM and GFUM, GMM, GIM and GFUM are calculated for 1 mole of the species, therefore equivalent weight is always calculated for 1 mole of the species. Therefore equivalent weight is also calculated for 1 mole of the species. That's one thing. Okay. Another thing is, I had already told you n factor is something which is variable. It will depend on the reaction in which it is appearing. Okay. So n factor is not always fixed. It can be different for Zn in a different circumstance. It can be different for Mg in a different circumstance. It can be different for Al in a different circumstance. So n factor is something variable. Got it? So if this is variable and we know that all these are basically constant for a particular species, these 4 quantities are constant for a particular species, but this is not constant, this is variable. So something constant divided by variable is equal to something variable. So equivalent weight it will usually be variable only. It will never be I shouldn't say it will never. Most of the times it will not be constant. So write that down. Very, very important point. Since n factor is dependent on the reaction or the situation. Since n factor depends on the reaction or the situation the species is in, the equivalent weight is also variable. Got it? This is very, very important point you need to remember. Okay, ji? Now there is something called so for example, we know these for all these species. We would be able to calculate these for any species. If we are able to calculate n factor, we will be able to calculate equivalent weight or not? I'm asking the question again. Since we know GAM, GMM, GIM and GFUM of all the species, if we do not know, we have ways to calculate that. There is no doubt in my mind about that. So if we can calculate the numerator, we know that, or we can say if we know the numerator and if we are able to calculate the denominator somehow, can't we calculate the whole value, which is equivalent weight? Can't we calculate equivalent weight then? Yes, we can. So we know this, we can calculate this situation by situation or reaction by reaction, and then we can calculate the equivalent weight of that particular species in different situations. If we are able to do that, if we are able to calculate equivalent weight, we will be able to calculate equivalence and we will be able to use the law of equivalence. Got it? It seems a little difficult to understand at first, but once you get the grip of it, like for example POAC, if we got the grip of it, then everything is done. Got that? So equivalent weight is this. Now we need to be able to find ways how to calculate n factor. So we are going to talk about that now. Calculation of n factors. Calculation of n factor. So n factor is dependent on something called acidity. A, let me write it as A, B, C, N, V. So we are going to take a look at these two today. This is called acidity and basicity. But before that, let's talk about n factor a bit. Write that. N factor of a substance depends upon the nature of substance, which it is showing, the nature which it is showing in a given reaction or problem. In a given question or a reaction, whatever nature it is exhibiting, the n factor will depend on that. Full stop. It can be any of the 5 categories. It can be showing acidity, basicity, some charge, something of that sort. So if we are able to identify that nature, we will be able to calculate the n factor in that particular situation. Okay, now right, let's take this to example. Just for example, if we have H2C2O4, okay, here it is in +3 oxidation state. It can behave both like an acid or a reducing agent. Okay, right? So let's take both the examples. It can behave like an acid and a reducing agent. Okay, one thing, whichever is behaving like a reducing agent, it always gets oxidized. So let's take a look at this first. If you want to know the structure of this, it is this COOH. You have not even seen this. Let's do this. This is the structure of H2C2O4. That means it has 2H plus it can give. So we can say that it can give 2H plus C2O4 2 minus. So here it is behaving like an acid. In this example, the other one, it is behaving like a reducing agent. Like basically it is getting oxidized into CO2. Okay, it is getting oxidized into CO2, so we will get CO2 in this case plus H2O somewhere, something of this sort. I'm not writing the whole equation, but you can see that it is in +3 state and here it is in +4 state. Got it? So you can see that it is getting oxidized. It is behaving like a reducing agent. Here it is behaving like an acid. Here it is behaving like a reducing agent. So n factor in this situation will vary from, it can be numerically same. It does not have to always mismatch. Okay, but the way we will calculate this and this are two different things. Here I will say for an acid, the number of H plus ions it gives, that is equals to n factor. So n factor will be 2. I'll give you the definition, don't worry. For an acid, number of H plus ions it can give is its n factor. It can give 2 H plus ions, n factor is this. Here you can see for one molecule, how many electrons is it donating? +3 to +4. If we balance this, that means +6 to +8, that means 2 electrons are being given by this. Here also we can see that it is n equals to 2. Number of electrons lost or gained per mole of that species is called its n factor. So in both the ways, the nature or the behavior of H2C2O4 is different. That's why the method with which we are calculating its n factor is different. in this particular case, it came out to be the same, that is n equals to 2 for both these. But apart from this, other than that, you will always have to go through the nature. Got it? It will always be different. Okay, got it? So this is what I wanted to convey. Okay, and let's take another example. If, for example, as an acid, it gave only one H plus, and we got, let's say, this is what we got. In this case, n will be equal to 1. So when it was giving 2H plus, n was equals to 2. When it is giving just 1H plus, it is its n factor is equals to 1. So depending on the situation and the behavior, we can see that n is variable. Got it? So it depends on what? It depends on several factors. So for example, if it is behaving like an acid, we will talk about basicity, and if it is something is behaving like a base, we will talk about acidity. Okay, so let's talk about first acidity. Okay, let's first talk about acidity. What is acidity? You will say, sir, acidity जो पेट में होती है, acidity, something that we encounter in our stomach, for which we take some antacid or Eno or whatever. That's not the acidity we are talking about over here. We are talking about the number of, like, acidities are defined for only bases. You will say ki we are talking about acidity. How is it like defined for bases? Bases can give OH minus ions which can react with H plus, or bases can actually absorb H plus ions. So acidity is something, it is the capacity of the base to be able to absorb H plus ions, or to be able to react with H plus ions, to be able to react with some acidic thing. Got it? Acidic species. So acidity is defined as the number of OH minus. There are two definitions based on which base it is. If it is Arrhenius base, then the first definition. If it is Bronsted-Lowry base, it is the second definition. Write that. Right. Acidity, first thing is, it is defined for bases. Second thing is, acidity is the number of OH minus ions given by a base, given by per mole of the base. Got it? Or acidity is the number of H plus ions absorbed, per mole of the base. ठीक है? Got it? Like for example, NaOH, if it is giving you Na plus OH minus, we can say that acidity is equals to 1. Let's say NH3 plus H plus, let's say it gives you NH4 plus. Here you can see that it is absorbing one H plus ion, so acidity here is, it has nothing to do with the acidic strength of an acid or a base. Okay? It just has to do with how many OH minus is it giving, or how many H plus ions it is absorbing. Got it? That's the first thing. Second thing, N is equals to, N factor basically is equals to acidity for a base. You can write that. N factor is equals to acidity for a base. Okay? Got it? So using the equivalent weight formula over here, we can say that equivalent weight of a base is equals to gram, let's say molar mass. Instead of writing all those four, I am just writing molar mass of base upon acidity, because like we have just replaced N factor from that formula with the acidity. That's it. Got it? So this is the basic. This is how you will calculate the equivalent weight of any base. Okay, now again I told you it depends on the situation. Okay, let's take some examples. Okay. Okay, so according to two definitions, one is the number of OH minus given. Okay, for this we do not need a particular reaction. Okay, so there are two ways of going about it. First is when reaction is not given. Okay, let's take an example of NaOH. NaOH, we already know that it gives Na plus OH minus. Since it is giving 1, we will say that A is equals to N is equals to 1. Or let's put it like this, N is equals to A is equals to 1. Second, let's say CaOH whole twice. It will break up as, so how many OH minus? 2. N equals to A is equals to 2. Same, Al OH whole thrice, it will give you Al 3 plus. When reaction is not given, and you're like here I am giving you reactions, so this is not a reaction. I'm just saying if NaOH is given, how will you calculate its acidity? Basically it will give this only, na? That's how. You don't really need to write these equations. You can see that there is one OH over here, there are 2 OH over here, there are 3 OH over here. So we can say that its acidity is equals to 3. Got it? Let's take example of NH4OH. If in this one we can get NH4 plus OH minus, that is N equals to A equals to. Got it? So this is very easy. Because when a reaction is not given, you just have to count the number of OH ions there. That's it. Got it? This is how it is. There is another way in which, before we go, write something. Though N factor depends on how the base is reacting. I told you how the base, like for example, this acid over here can behave like this as well as this. Based on both the behaviors, the N factor is changing. Basically, the basicity is changing, so the N factor is changing. Got it? Now, here as well, it should happen. But since reaction is not given, we are going to just use this. When reaction is given, it is a different story altogether. So write this. Though N factor depends on how the base is reacting, in a particular reaction, its acidity can be calculated. By the above method, when the reaction is not given. Now I am going to take a look at when the reaction is given. Let's say, right, next B, write it as B. When the reaction is given. When the reaction is given, we have to see how many OH minus is it giving, or how many H plus ions is it absorbing in that particular reaction. We don't have to go, like for example, when the reaction was not given, we said that N is equals to 2 or A is equals to 2 for this. But for example, if this does not behave like this in a particular reaction, it behaves something like this, that it just gives 1 OH minus ions, then N factor will be equals to 1 only. Got it? Let's take some example. Got it. So this is defined for oxides, carbonates or bicarbonates, etc. Okay? Plus bases, normal bases. If you will see, these oxides, carbonates and bicarbonates are basically bases. These are conjugate bases. Got it? Since these oxides are since these oxides or these species are basic, they can attract H plus ion. Got it? So let's take a look at these things. Like for example, NaOH plus HCl. This is the reaction given. Same way, NaOH plus H2SO4, Na2O plus H2SO3, MgO plus H3PO4. Let's do these first. So in this one, what will we get? NaCl plus H2O. The H and OH minus will combine to give H2O, and NaCl will be the salt. This is balanced already. Is this balanced? No, because it will give Na2SO4 plus 2H2O. Okay, here we'll have to write 2. Got it? Again, here you will get Na2SO3, Na2SO3 plus H2O. This is balanced. Now, again this one. Here it is giving 3 H plus ions, and it will be able to give, take, like for example, what will we get? We will get Mg3PO4 whole twice. So if it is 3, we'll have to write 3 over here, and we'll have to write 2 over here, plus how many? 6, 3H2O. So you can see that in these reactions, all of these are reacting in a particular way. Here it is giving 1 OH minus ion. So N factor for this, or A for this is 1. Here it is giving 2 OH minus, isn't it? It is giving 2 OH minus to 1 mole of H2SO4, but 2 OH minus ions for 2 moles of NaOH. So per mole it is giving only 1 OH minus ion. That means A is equals to 1. Here you can see for oxides, how many H plus ions is it either absorbing or replacing? For example, here you can see 1 Na2O, or like this let's consider this to be the oxide. Let's talk about this. This oxide has taken 2H to make H2O. That means this whole species has taken 2H plus ions to give the product. That means the N factor over here, or the acidity over here, is 2. Same way here, you can see that this is 2 minus, this is the oxide. Oxide is taking how many hydrogens? 6 hydrogens for 3 different 3 oxide ions. For 3 oxide ions, it is taking up 6 hydrogen ions, hydrogen H plus ions. That means for every oxide ion, it is taking just 2 H plus ions. That means here as well, A is equals to 2. We just have to see how many hydrogen atoms or ions is 1 ion of oxide is absorbing. We just need to see that. Got it? Okay. Let's take another example. CaOH whole twice plus 2HCl. CaOH whole twice plus HCl. ठीक है, Na2CO3 plus 2HCl. ठीक है, 2 NaHCO3 plus H2SO4. If we take a look at this over here, 2 OH minus will combine with 2 H plus. So what we can say is, basically in this reaction we will get CaCl2 plus 2H2O. We can say that every molecule of CaOH whole twice gave 2 OH minus ions. That means A will be equals to 2 over here. Here you will see something different, which is CaOHCl plus H2O. Okay, so here this CaOH whole twice molecule gave just 1 OH. That means A is equals to 2. Got it? Here, this is a carbonate, how many H plus ions this carbonate has absorbed, we'll have to see. So we will get H2CO3 plus 2NaCl. So 1 CO3 2 minus absorbed 2H plus, that means A is equals to 2. Here again, this is bicarbonate. How many hydrogens is this bicarbonate accepting from here? So you will see Na2SO4 plus 2H2CO3. So every bicarbonate ion absorbed 1 H plus. So we will get A equals to 1. Got it? When we have A equals to 1, when we have the N factor, we can calculate the equivalent weight over here. So let me do that for you as well. Here the equivalent weight will be E will be, this is 40 by 2. Then again this is 40, again it is this E equals to 40 by 2. Na2O, this is 46 plus 16 is 62. Okay, so E will be equals to 62 upon A kitna hai? How much is A? 2. Again this E will be equal to 24 plus 16, 40 upon 2. Getting my point? ये 1 आएगा रे. This will be 1. Why am I writing 2? My bad. This is 40. This is 40. Got it? Same again you can do. Excuse me. 40 plus 34. 74. 74 by how much? 2. So E is equals to 74 by 2. E is equals to, oh, here it will be A equals to 1 because it has given only 1 OH. So here it will be 74 by 1 and Na2CO3, this is 60, this is 60 plus 46, 106, E equals to 106 upon 2. Then again E is equals to, this is 24 plus 60, 84 upon 1. This is 53, this is 84, this is 74 and this is 37. So you can see we can calculate the equivalent weight of all of these just because we know the acidity. We know how to calculate the acidity now. Got it? Let's take a look at basicity because basicity is based on acids now. Okay? Basicity. Okay. Right, the basicity is defined for acids only. Okay, write that. The definition of basicity will be, there will be two definitions. It is like basicity for an acid is equal to the number of H plus ions given per mole of the acid. The number of H plus ions given per mole of the acid. Second definition is number of OH minus ions absorbed per mole of the acid. Number of OH minus ions absorbed per mole of the acid. Got that? Again, N factor in this case will be equal to basicity. Okay, and the formula for equivalent weight for acid will become molar mass of the acid upon basicity. Got it? Now for example in HCl will give you OH plus plus Cl minus. Okay, let's say NH4 plus ion, it is absorbing 1 OH minus ion to give NH4OH. So we can say that this is absorbing 1 OH minus ions. For this B is equals to 1. Here B is equals to 1. So you got the examples. Again, there are two ways. One is when reaction is not given. When the reaction is not given, like any acid, for example HCl, we will write it how is it going to break up it is going to break up as H plus plus Cl minus. That means it is giving 1 H plus. That means N is equals to B is equals to 1. Got it? So these are the examples. 9411. Okay. Got it? Then again, more examples. H2SO4. Let's take H2SO4. H2SO4. It will give 2 H plus ions and 1 SO4 2 minus. So it is giving out 2 H plus ions per mole of this. That means the N will be equal to 2. Then again, if we have H3PO4, okay, H3PO4 can give you 3 H plus ions. When the reaction is not given, I am telling you, when the reaction is given, you will have to go up accordingly. Here N equals to, basicity is equals to 3. Got it? Let's take some more examples. Okay, let's take this example. This is very, very important. BOH whole thrice or H3BO3. This is called boric acid. Boric acid. This is used for the treatment of your eye sometimes. Let me switch it off. How much time is gone? 46. I think we'll be able to complete this. Got it? So this is boric acid. This does not give H plus like that only. It reacts with water to give this. BOH, whole 4 minus plus H plus. So when boric acid is poured into water, it gives 1 H plus ion and this species, this ion, okay, this anion. So per molecule of BOH whole thrice or H3BO3 or boric acid, we are getting 1 H plus. That means here N equals to B equals to 1 only. Got it? Okay. Here I want to take some more examples. One of them is this is very, very important because people make mistakes. For example, if we have H3PO4, we have already taken that. Let's say H3PO3, then we can at most get these HPO3 2 minus. And if we have H3PO2, then at most 1 H plus will be given out. Yeah. Okay. So here N can be equals to B equals to 2. Here N can be equals to B equals to 1. Got that? Number of H plus ions it is giving out in general. So this can give 3, this can give 2, this can give 1. Here if you want to write the structures of H3PO4, this is the H3PO4, this is and this is H3PO3 and this is H3PO2. So only those H atoms or ions which are connected to O can be given out as H plus ions. Here we have 3 H which are connected to O, that's why it can give 3 H plus ions. Here we have 2, that's why it can give 2. Here it is 1. The ones which are attached to P directly, they cannot come out as H plus ions. Got it? So that's the reason this is it. Okay. Now let's take a look at when the reaction is given. Okay. The B is when reaction is given. Here we can have oxides, ammonium ion, etc. Okay, do we have anything else? Yeah, or salts. Okay, so let's take examples over here. Let's take example of this only. It will make it very, very clear. H3PO4 plus 3NaOH will give you Na3PO4 plus 3H2O. Here you can see that it has given out 3 H plus ions. That's why it's N equals to B equals to 3. If it behaved like this, let's say if it behaved like this, it would have been like Na2HPO4 plus 2H2O. You can see that here it has given only 2 H plus ions, 1 H plus ion it has retained. So here N equals to B is equals to 2 only, because it has given only 2 H plus ions. Again, if we have H3PO4 plus NaOH, just 1. So we will get NaH2PO4 plus H2O. Here you can see that it has given only 1 H plus ion and has retained 2 H plus ions. That means the N or B will be equal to 1. So you can see, in general, if the reaction is not given, we can say that its N factor is, or basicity is 3. But when the reaction is given, it is depending how it is reacting in the reaction or behaving in the reaction. Got it? Got my point? So this is the thing. You have to be very clear about this. N equals to B equals to 1, N equals to B equals to 2, N equals to B equals to 3 in these 3 cases. Like for example, let's say oxides. Okay, let's take examples of oxides. Oxides. Let's take example of oxides. For oxides, let's say CO2 plus H2O. Here you can say this come out to be H2CO3. Okay. Okay, not this one. Let's take this CaOH whole twice. This is called slaked lime. Okay. If you pass CO2 through slaked lime, you always get this CaCO3 plus H2O. So you can see that one molecule of CO2 has combined with or has absorbed 2 OH ions. Okay, so here you can say that N is equals to B is equals to 2. Here it has absorbed 2 OH minus ions. Okay, that's why its basicity is 2. Got it? It's so simple. Nothing to really think about. Just go by the equation. Another thing that I want to mention about this is CO2. When you this is the test for CO2, that you blow CO2 through a solution of KOH or through CaOH whole type, slaked lime, you always get lime, CaCO3, limestone. Got it? Which is basically insoluble in water. You can see whiteness in the water, which will give you the indication that whatever gas you pass through that solution contains CO2. Got it? Let's take N2O5. N2O5 plus NaOH. Here, just a minute, N2O5, if I give you H2, 2NH3, okay. Let's say we will get NaNO3, 2NaNO3 plus 2NaNO3 plus H2O. Here you can see one molecule of this is absorbing 2 OH minus ions. 1 mole of this is absorbing 2 moles of OH minus ions. Then in this case again, N will be equals to B will be equals to 2. Getting my point? NH4Cl, let's take this example, NH4Cl plus NaOH. If we are reacting these two species, you can see this product. See, you don't have to remember these equations. If you remember these equations, it's well and good. But if you do not, they will always be given so that you know how the particular species is behaving in that particular situation or reaction. Got it? And you will get NH3 plus H2O. Here you can see that 1 mole of NH4Cl is reacting with, like 1 mole of ammonia salt is reacting with NaO, 1 mole of OH minus. That means the N should be equal to, B should be equal to 1. Okay, let's take example of SOCl2. SOCl2 plus NaOH. Okay, right. Here the reaction is Na2SO3. Na2SO3 plus, if it is 4, this is 2, plus NaCl, 2NaCl, plus how many H2O? 4, 2H2O. So the reaction will be given, you might have to balance it. Like I am balancing it. Okay, the reaction is given, I am balancing it. So here you can see that 2 moles of SOCl2 combined with 4 moles of OH minus ions. That means per mole of SOCl2 it is combining with only 2 moles of OH minus ions. Here you can say that N equals to B is equals to 2. Got it? So basically it is equals to, just a minute, Na2SO3. Oh, okay. I think I have not balanced it correctly. NaCl. Right, okay. So N here, 1 mole of this is reacting with 4 moles of this. So we will get N equals to 4. Getting it? So here that like we can see that just by either looking at how many H plus ions it can give or looking at the equation in which it is reacting, we can calculate the basicity, which is the N factor, and if we are able to calculate the N factor, we will be able to calculate the equivalent weight. So here, just bear with me. Here E will be equal to 36.5 by 1. Okay, here this is E equals to 98 upon how much? 2. Here again 98 upon, sorry, here again B is I think 11 and 11 plus 51, 62 by 1. Okay, here again you can see E equals to, it is N equals to 3, 98 upon 3, E equals to 98 upon, okay, like we have not done this. H3PO3 is 51 plus 31 is 82. So E equals to 82 upon 2, and this is E equals to, this is 31, 32, 63 plus 3, 66 upon 1. Okay, now here we can say it is like it is taking up 2OH minus, B equals to 2, so 98 by 2, E equals to 98 by 1. Here CO2, E equals to 44, which is the molar mass of this, upon what is this is 2. Here E is equals to N2O5, 14, 28 plus 80, 108. 108 by how much? 2. Again here this is 1 only, NH4Cl, this is 18 plus 35.5, 35.5, 15, 53.5. So 53.5 upon 1, E equals to this, and here E will be equals to S and O. 32 plus 16, how much is it? 48. 48 plus 71 is 119 upon 4. So you can see just by calculating the acidity or basicity, we can get an idea of what N is, and if we get an idea of what N is, we will be able to calculate the equivalent weight. Just let's first calculate N factors and then just be able to calculate equivalent weights. Once we are able to do that, then we will move on to how to calculate equivalents, and once we are able to do that, there is no limit to, like, you don't need the mole concept, but for some people mole concept seems to be a little easier as compared to equivalents. Those people use mole concept. Some people prefer POAC. Okay, so I personally prefer mole concept. It is like easier than this, because sometimes you can make a mistake in these calculations, and which is not a very good thing about it. but sometimes there is no other way except for equivalents. So you have to know this method. So if you have learned something new from today's lecture, if you have some of your concepts which were misconceptions and which you got cleared today, do like this video, share it with your friends, do put a comment of appreciation and subscribe to the channel. And if you found something which you did not or could not understand, you can put it in the comments, or you can contact us on the number given in the description of this video. Have a great day. Bye bye. Take care.